Let's identify force pairs in a system. So we have the Earth and the Moon is not going to float off into outer space. It's going to stay in orbit around the Earth. And the Earth feels a force from the Moon because we have the ocean. It bulges out. We call that tides. And it also wobbles a little bit as well. What is that force that connects the Earth to the Moon? The gravitational force acts between the Earth and the Moon. But which object feels more force? Does the Earth feel more force? Does the Moon feel more force? It's a lot smaller and the Earth's a lot bigger, so maybe B's right. Maybe the Moon feels more force. Or C, do they both feel the same amount of force? What's the answer? If you said C, you are correct. They both feel the same amount of force. We've got the force of gravity of the Moon on the Earth, and that is equal and opposite to the force of gravity of the Earth on the Moon. We have an action and a reaction because Sir Isaac Newton said for every action, there is an equal and opposite reaction. And there that is right there. But a better way to think about it is thinking about them as force pairs because forces come in pairs. Every force is a pair of forces acting on two objects. So what is the type of force occurring here where we have this person on a wagon being pulled by someone using a rope? What force is that? That's the force of tension, and that's acting between Eric and Ariana. But let's be a little bit more physicsy and let's identify the system. Let's call that the force of tension that's acting between the Eric and wagon system because those objects are going to be sort of moving together and Ariana. So let's just identify the system here. So what are the force pairs? I would draw them like this. So we have the force of tension, and I drew that on the Eric and wagon system, and we have the force of tension, and I drew that on Ariana. The forces are equal in magnitude. Magnitude just means amount, but opposite in direction. They're pointing in different directions. Ba-bam. Now here's a pro tip. Label the force vector with the force type and the objects involved. So we're going to label the force vectors just like this. Let's get a little bit of closer look at it. So I labeled on the left the force of tension of Ariana on the Eric and wagon system. And over there on the right, I have the tension force of the Eric and wagon system on Ariana. So Ariana on the Eric and wagon system, Eric and wagon system on Ariana. That's how you can hear force fairs. They just flippity floppity, and it's the same type of force. Okay, so here's a misconception, and that's why we like to teach it like this. We have a pencil, and it's sitting on a desk, and a student has drawn a great free body diagram for this pencil, and they have the normal force, and they have the force due to gravity, and they get a question like this. What is the force pair to the normal force on the pencil? So what is the force pair to that normal force that's shown right there? And you know what most students do? They go, gravity. But that's wrong. That's totally wrong because they think, oh, look, it's equal in amount, but it's opposite in direction. But that's not a force pair. Balanced forces on an object are not force pairs. They are not force pairs. So how do we find the force pair? Let's use our pro tip. Let's label the force vector with the force type and the objects involved, and we'll figure it out like so. If we have the normal force on the top here, the normal force of the pencil, right here, the normal force of the table on the pencil, what is the action-reaction pair or the force pair to that force? Because it's not the force due to gravity. That's a whole different force. What is the force pair to the normal force of the table on the pencil? Boom. This is how you identify force pairs. Force pairs occur between two objects or two systems. I have now drawn a normal force on the table. Look, I'm here now. Boop. I'm here now. I'm looking, that center of mass now is drawn on the table, not the pencil. Two objects. Two objects. And just, I think I may have said this, but a force pair is the same thing as an action-reaction force or Newton's third law force. But the force normal of the pencil on the table, that's the force pair, to the force normal of the table on the pencil. And that's how you hear it, remember? Of table on pencil, of pencil on table. Easy peasy lemon squeezy. Last thing. So we got an astronaut. He's throwing a basketball. And this is what confuses students every once in a while.